Hi, now we're going to make the first assembly for Lab 5. So I'm in SOLIDWORKS here. I'm going to create a new assembly. I'm going to verify that Y is up, and let me cancel out of this first, and let me make sure that my units are set to, in this particular one, we want them to be MKS. Alright, so I'm going to go to Insert Components. I'm going to browse to the Lab 5 articulated bucket folder, and I'm going to bring in the part called Base Arm 1. I'll click Open, and to insert the part at the origin, I'm just going to click the green check mark. Okay, and the next thing I'm going to do is I'll go back to Insert Component. I'll browse to the part called Piston. I'll select Open, and I'll just drop it here into the work area, and then I'm going to use my mate tool to set a concentric mate. So I'll zoom in, select the cylinder and just any portion of that cylinder, and I'll say OK, and I can drag it kind of into the right position. I'm not going to fully define this one yet. That gets done in another step a little bit further on. So I'm going to say OK, and I'm going to insert the other part of the base arm 2, and I'll select Open, and I'm going to drop the part here. Alright, so I'm going to set this using 2 concentric mates and a coincident mate, or there's lots of different ways of doing this. So I'm going to select mate, I'll select here and here. Alright, so now I can go back and forth and rotate. So to lock its position back and forth, I'll see that it has this little tab here on the bottom. I'll select that and this face. So that puts it, and then it can still rotate again. So then I'll just select this cylinder and this cylinder, and that puts them fully defined. So you'll note that my assembly is still underdefined because the piston isn't locked down yet. We'll do that in the next step, or the 2 steps later on. So now I'm going to insert the lifting arm. So this is the big part. So I'll bring it in and I'll just drop it. And again, I'm going to utilize mates to define its position. I'll select this cylinder and this cylindrical knob on the base arm to lock its rotational position. Now it can still slide back and forth, so I can select this face and this face, make those coincident, and if I view it from the back, you can see that it can't move back and forth, but if I look at it this way, it can move up and down. So what I want to do is I want to lock its angular position. So I'm going to come over here to the angle mate. I'm going to put in 140 degrees, and I'll select this face and this face. So that's not what I wanted, so I'm going to flip the mate alignment, and that gives me the angle that I'm looking for, the 140 degrees. So I'm going to say OK. Alright, now what I'm going to do is I want to turn on the visibility of planes. So I'm going to come up here and turn on the visibility of planes, and you'll note that the front plane of the base arm, of this arm, is visible. That's because if you look at the way the part has been designed, its front plane has been set to be visible. So you can do that when you're making a part if you think it's going to be useful for positioning it within an assembly. Okay, so the next thing I'm going to do is I'm going to bring in the part called the cylinder. I'll click Open, And the first thing I want to do is I'm going to rotate it around the z-axis twice. Just get it into the orientation that I want. Okay, and now you'll note that it also has a front plane that's visible, but you can see that they're not aligned. So what I'm going to do here is I am going to mate the front plane of the lifting arm to the front plane of the cylinder, and that aligns those. Then I'm going to use a concentric mate, so the cylinder of the central part of the cylinder to this cylinder here of the lifting arm. So that puts them together. And then the last thing that I have is, okay, and the last thing I want to do is set the concentric mate between this part and this part, and SOLIDWORKS automatically aligns the parts and makes them concentric to each other. Okay, so that has put all those together. Now the next thing I need to do is I need to put another piston cylinder setup up top here. So I will bring in the cylinder up here. I'm going to go to the mate tool, select the two faces, the two front planes to line them up, select their respective cylindrical faces to line those up. That allows this to move. I'll bring in a piston. I can bring it in here. Again, I can rotate it around the z-axis to get it approximately in the right position that I want. And I'll go to mate, and I'll select this cylinder and this cylinder and get those lined up. All right, the last thing I want to do is I want to bring in, or the last part that I'm going to bring in is going to be the bucket. So I'll insert the bucket. And this also has a front plane. So I will mate the front plane of the bucket to the front plane of the lifting arm, and that gets those all lined up. That's all I need the front plane visibilities for. So before I do anything else, I'm going to turn off the visibility of planes, clear up the view a little bit. Now I need two concentric mates. So I'll select this cylinder and this cylinder, and you'll see that the bucket now can rotate back and forth. I'll select this cylinder and this cylinder. All right, and if I view it from the right hand now, you can see that the bucket can still move back and forth. So I can set that by adding an angle, and what I'll do here is I'll set the angle mate to 50 degrees, and I'll set this plane and that plane and that, and if I view it from the front, I can verify, or from upside down, that's not what I wanted the front view. That is the angle that is shown in the document, so that's what I want. All right, and then the last thing I want to do is we have the ability to put in our own coordinate systems. So say for some other reason, whatever reason, you want to know what the center of mass is with respect to a certain location on this assembly. We can do that by, under the Assembly tab, I can go to Reference Geometry and choose Coordinate System. Oh, before I do that, well, let me just turn on the visibility of coordinate systems first. So under the eyeball, I'm going to turn on coordinate systems. And now I have the coordinate system tool open, and I'm going to select this point here to place the new coordinate system. You can check out the colors of the arrows, that by default it has the same orientation of the base coordinate system. That's actually what I want here, so I'll say OK. And you can see that there's a new element in the feature manager called coordinate system 1. All right, so now what I want to do is check out where my center of mass is. I'll click on the Evaluate tab, go to Mass Properties, and I want to report the coordinate values relative to the new coordinate system. And those are the values that are given in the lab document. So those are what we want. All right, so now one other thing. So I'm controlling the position of this assembly using essentially two angle mates. What I can do here, if I open up the mate folder, is I can left click on the first angle mate, and the option is to suppress it. And I can do the same thing on the second angle mate, and I can also suppress it. So when I do that now, you can see that now I have these 2 degrees of freedom left. So what I'm going to do is control these now using distance mates. So I'm going to go into the assembly toolbar, select mate, and I'm going to click into the distance mate. I'm going to put in a distance of 0.2, and I want that to be between the cylinder and the piston, but I can't see the piston inside here. So I'll left click here. Oh, I should have done that first before let me cancel this. I should have made it transparent first. So I'm going to left click, and from the options here I want to change the transparency of that cylinder. I'll do the same thing here, left click on the cylinder and choose the change transparency option. So now they're both transparent so I can see them. I'll go back to the mate tool. In this case I'll set my distance to being 0.2, and I'm going to select the face of the cylinder and the face of the piston, and the distance will be 0.2. And for the other one, I want to set the distance to be 0.6, and I'll come in here, select this face and that face, and set the distance to be 0.6 meters. I can view it from the front and verify that that looks like the diagram in the lab document. I can also verify the center of mass as being what's provided in the lab document. Okay, and now for the last thing that you want to do for exercise 1A and 1B is you need to change these angles and dimension mates, or distance mates. So I'm going to suppress these 2 distance mates. So now I can turn on my angle mates back on. And where's the other one? Here. Sorry, I didn't want to undo it. Sorry. I want to unsuppress it. I didn't want to edit it. And now what I can go through is I can go ahead and then edit the mate. So if I want to edit this to changing from 140, I think the first option is 160. I can do that. And I can go ahead and change the other mates as I need it. And then for the second part, you will then again suppress the angle mates, unsuppress the distance mates, and put in what you need. All right, so that's how you're going to do this one. And then finally, you're going to do a 4-view representation. So don't forget how to do that. And you'll select the front, top, right, and isometric views. All right.